Hey all, and welcome back to Radical Slice. My name is Eric. This is part 6 of my harried attempt to implement a version of some classic Zelda dungeon mechanics using Pico-8. If you haven't seen the other parts, I'll link the playlist in the description, so feel free to check those out. Anyway, last time we started on our room stuff. That is, like getting the player to move between the rooms and having the camera make those jumps at the same time. We made some good progress there, but currently we've tied the room movement to a button press. So it's really manual, and obviously we can't really leave it like that. So this time we'll wrap up the rooms, I promise, and get that darn camera doing what we want. So let's rock and roll. All right, so just thinking about how to right now we're doing the room changes via a button press, which is ridiculous, and we don't want to do that long term. So how can we think about this? What I'm thinking of right now is we have these sort of we have this table full of rooms, and get my brush working here. Right now, each room doesn't encode too much data, right? We talk about a room has some baddies. It may have an item. The other thing I want to encode here is actually the doors. And the reason I want to put this here is because, as we said, each door has to encode like several bits of information. One is it has to have a position, right, an XY position, where it's located, 1, 2. And it also has to encode some information about which direction to move the camera, right? So each door has to have a few pieces of information. One is like the position, X and Y. The other is which direction to move the camera. So we'll call it like next room index or something. And also which direction the player should be facing in which to trigger it. Because again, we don't want the player to always trigger the room change just by stepping on the tile, because that would be weird. It would cause all sorts of looping problems. So we need to encode some data about like the direction that the player should be facing. Okay, so each room, in addition to containing baddies and items, will also contain these doors, and we will check for collision with the player and the doors, just like we check for collision between the player and the baddies. So let me get started on coding that up. All right, so I sort of followed the pattern that we used for the baddies, which is to create some sort of manager for these doors. We associate the doors with the room. All right, so they're sort of in the room structure. And we create a new door at each of the positions listed in the room structure with the X and Y position. And we give it some height and some width. We're going to have to update this a little bit because sometimes doors will be wider than they are high, depending on the direction, right? Actually, let me just add that now. Okay, we're going to set the height and width of the door depending on direction. And when we call the sort of load level function, or sorry, load room function, one of the things we're going to do after we load the baddies is also to load the doors. And I'm just printing some debugging info here. You don't have to pay any attention to that. Similarly, when we draw the room, we're going to call draw on the baddie manager and draw on the door manager. So each of the doors here will be passed into the draw door function. And depending on the direction, it'll use a different tile. This is sort of overkill, but just for visualizing what we have so far, I wanted to use the different colored tiles to make sure each of our doors made sense. And we need to pass in the direction here and here. All right, let's see how far that gets us. Oh, right, so we need to put door that direction in front of all these. Let's try it again. All right, great. There's a door way over here, which is not where I want it to be, but we're off to a good start. think I did my multiplication wrong. Perfect, perfect, perfect. Okay, let me add the rest of the doors to the other rooms. Okay, so I've added the doors. They're not being drawn currently though, and that's because the doors aren't initialized and drawn until the room is loaded. So here's where things are going to get interesting. What we have to do now is trigger the event when the player steps on that first door. And at that point, we're going to load the next room and any baddies and any doors contained in it. This is going to be tricky. So the first thing I want to do is start adding collision to check for when the player steps on these tiles, assuming they're facing the right direction. And once they do that, I'm going to trigger the sort of room change process, during which, we'll reload any baddies, we'll unload any baddies from the first room, we'll load any baddies and doors from the second room. Away we go. Okay, so what I'm thinking of doing here is a couple of things. Let me get rid of my masterpiece here and start a new thing. Okay, when the player steps on this tile, a couple of things need to happen, right? One is, use black for this. The first thing that needs to happen is new room needs to load. All right, so new doors need to be set up, new baddies need to be loaded, etc. The second thing that needs to happen is the camera needs to shift. We'll call it the camera needs to move. These are sort of independent events, right? Like they're related and the player experiences them as one thing, but like logically, these are two different actions, right? Loading the baddies and the doors from the new room doesn't really have anything to do with where the camera is located, right? Similarly, the camera doesn't really give a gosh darn which baddies are loaded and which aren't, right? It's the camera. So the camera's concern should be like, I got to go from here to here, and that's it. So I'm going to split this into two separate events. And what's going to happen is main is going to trigger some sort of collision event, right? Say load room, right? And we'll send this to the game manager. The game M is going to do the room loading. Load that room. Once the room is loaded, our game manager is going to fire another event to tell the camera to move. And the reason we're doing it this way is because right now we have kind of a nice grid, right? Where our rooms are like nice and square, and we could like forcibly make them all the same number of tiles, length and width, right? Just to make our lives easier. That's not really realistic though. And that might be something that we want to include in our slice here. So what we're going to do is when main tells the game manager to load the room, the game manager knows the dimensions of the room, right? It knows the starting X and starting Y coordinates. And so that's the thing that's going to tell the camera like, hey, move yourself to this new X and Y place, right? And once the camera is done moving, then it'll pass control back. So it'll say, what was it like? Cam move finished. It'll pass control back to that sort of update loop. So we're going to do two separate events here to separate our loading of the assets in the room from the movement of the camera. Now, this might not seem great because it's like, oh, but like you're going to see things appear before the camera was. Yeah, but this is all going to happen in like a frame, right? So we don't need to worry too much about like any sort of like visual latency or anything, I don't think. But the first frame, what will happen is the game manager will load the room, and in the second frame, the camera will start moving. And actually, depending on how we do this, we could probably do it all in one frame, but we're not super concerned about that right now. So let me go ahead and code that up. Okay, one change I'm going to make here, and this is all going to tie together beautifully now. Remember, in our init function, we're loading the room at 1, 1. And when we way back defined our rooms, we did it in sort of a matrix that was a data structure that represented sort of the visual way our rooms looked, right? So room 1 is right next to room 2, which is to the right, and then below room 2 is room 3. So right now we're just sort of hard coding 1 and 1 here. What I'm going to do is I'm going to take the 1 and 1, and I'm going to make those, I'm going to put them into the global state as like the current indices into our room matrix. And rather than loading 1, 1 explicitly, I'll just load current room X, current room Y. All right, nothing has changed so far. Okay, and in our sort of load room handler, so this is the thing that's going to catch that first event. So what I'm looking at is sort of this part right here. All we're doing is looking at the payload, and we assume in this payload there's going to be a new value for X and a new value for Y, or sort of an offset, right? It's probably going to just be +1, -1, that sort of thing. And we're going to add those values, whether it's plus or minus, to the current room values that we just set in main, right? So you can assume here if the player is moving from the left to the right, and they're moving to the new room on the right, this new room X will be +1, right? So current room X is now going to be incremented by 1, which will allow us to load the room from here to here, right? We're sort of loading this new value, which would be room 2. Similarly, if we moved from right to left, we would expect that new room X would be -1, which means current room X would be 1 less, which means we'd be moving from room 2 to room 1, right? And the same works for the column values. Now, this will force us to be really careful, because obviously if we try to increment past room 2, all sorts of bad things are going to happen. Actually, probably it'll just crash, right? So it's not the end of the world. But we sort of have to be very aware of what our room's data structure looks like and what sort of values we're passing to our load room function, because they may be nil, or they may not exist. In our main, we need to figure out where to call this load room function, which is when the player steps on that tile. So let's go to collides. Okay, so what I've done here is we're checking each door for collision. And if the player not only collides with the door, but also their direction matches the door's direction. So if the door's direction is right and the player is facing right, then we're going to create an event. And in that event, we're going to include the new room X and new room Y position, which again are just the indices into our room's data structure, right? So, or like the offset that we want to do. So if we're in room 1, the player is facing right and steps on a right door, we're going to pass +1 and move here. If the player steps on, or I'm sorry, if we're in room 2, the player is facing left and they step on a left facing door, we're going to send -1, and we'll send the player back to room 1 this way. I have a feeling this is not going to work the first time, but let's just load it up and see what happens. Okay, it didn't work, and that's okay. Let's see what happened there. Okay, great. So yeah, I had my doors configured incorrectly. This should be, sorry, in room 1, the direction here should have been 1, because that corresponds to the right-facing door. So I had my 0 and 1 flip there. Okay, so the problem that I'm running into now is, in addition to confusing my left and right directions in a couple of places, there's a collision, and we start to trigger the room shift, but we didn't change the update function yet. So what's going on is the player steps on the green tile, it increments the room index, and it tries to and it loads the room. But right now the player is still standing on the tile and collision is still being checked. So the room just keeps getting checked over and over again, and we end up looking for rooms that don't exist. So we need to update the update function, change the update function so that we are only checking for the collision once and then sort of stopping the world to do that shift. Okay, that seems to have worked. So the world is stopped. And the new room is being loaded. And so we've done this part. Let me use a different color. We've done this bit. But right now, the camera isn't moving because we haven't told the camera to move yet. So we need to set another event that the camera will subscribe to so that it does its movement thing. Let me do that now. Now, initially, just for debugging purposes, I'm just going to send an event that says can move start, and we'll have the camera just move some fixed distance, right? So we can copy actually that like plus 64 thing. We're not going to worry about the direction first. What I want to do is test the logic that after the new room is loaded, then the camera gets this event and does its motion. And then once we've got that set up, we can decide how to communicate the target coordinates for the camera. So we actually got pretty close that time. Let's see here. We'll load main. We'll run. The player steps on the tile and the thing advances, which is good. The problem is, though, we're not advancing the player's position. So even though the room changes, which is what we want, our player is still stepping on that tile, right? Which is not great. So what we actually want to happen is for the player's position to sort of be cheated a little bit. So we can also use the sort of cam move start event to advance the player's position. So let's add sort of a cheating event here. We'll allow the player to subscribe to the same cam move start event by just changing this to add subs. And we'll pass in player.handle cam move start. And then we'll add some functionality to the player so that it advances some number of pixels. Again, to cheat. Okay, that was pretty good. So again, just like I'm sort of, let me move some stuff around. Just like we sort of hard coded the plus 64 to the camera, we're also hard coding a plus 16 to the player to sort of get them to move off the tile so we don't have multiple collisions. I think what we can do is just pass in some sort of directionality component into the payload here. There will be some sort of payload so that the player, it advances either plus 16 or minus 16 in the X or Y direction. Similarly, with the camera, we're going to have to figure out the delta between the current room and the next room. So this is also going to need some sort of payload information. So let me work on that now. I was just thinking for the player update, the player doesn't really care the room start and end point. Like the camera cares about the delta between one room and the next, but the player doesn't. The player just cares about the direction. So I think rather than handling the cam move event, we can handle the load room event and update the position there. So let me update the subscription accordingly. And actually, I just realized that the player doesn't need the direction from the payload because the player knows its own direction. So we can just base our conditional and our position update based on that. Okay, cool. That seems to be working pretty well. However, the door is not loading. Why is that door not loading when we load the new room? So I've actually realized that I named my variables pretty poorly here. Rather than current room X, current room Y, and new room X, new room Y, I want to use rows and columns because that's the terminology I'm using elsewhere. So let me update those now. All right, great. All right, so I had to unify some language here. I was using current room X and Y for my variables, and that was just sort of confusing me in terms of which arguments to pass to load room. So I just updated the naming to be row and column so that it was clear like what I was talking about when I was moving through this structure. This being rows go, this is row 1, and this is row 2, and then col 1 would be room 1 and nil, and col 2 would be room 2 and 3. So now we notice that, let me reload here. Now we can see that when the player moves when the player gets dumpstered by these goblins here. When the player moves from one room to another, it loads the new doors. And one quick bug that I need to take care of is that the doors are drawn on top of the player. So let me fix that now. And jump. Cool. Cool. Okay, so yeah, now the other problem is we've hard coded everything to move to the right for the camera, so we need to go ahead and update the cam move thing so that it can move not just left and right, but up and down as well. I'm actually going to make one change to the load room function. So right now we're updating our current room pointer directly, and what I want to do is actually return a value here. I want to return the new room. I don't know if I'm going to regret this or not, but I think it'll make our code a little bit cleaner, a little bit easier. So we'll call this new room, and we'll set it to nil. And then if this is not nil, then we'll update new room to be here. We'll even update our debugging. And then we're actually going to return new room. So now when we call this, rather than updating the current room inside the function, we'll set current room is equal to the result of load room. What we're trying to do here is tell the camera how much it needs to move, right? So we need to know sort of the delta between the old room and the new room. And we can do that here because up until here, right, the current room is still pointing to the old room. And then at this point, we know where the new room's coordinates are. So what we can do is sort of store the upper left corner of the current room and compare that to the upper left corner of the next room to get our delta for the camera to move. Let me just sort that calculation out now. All right, so we're doing the same thing twice here. All right, we're looking at the current room and taking the X and Y values for its upper left-hand tile. Then we change the current room, and then we look at it again, and we put the upper left and upper right-hand corner, the upper left-hand corner of the X and Y tiles into new X and new Y. Now, if we compare cur X and new X and cur Y and new Y, we'll know how many tiles the camera will need to move. So we just take that value, multiply it by 8, and pass it into cam move start. We should be good to go. Okay, hopefully those numbers will make sense. Let's go into the camera and adjust this handler. So we know we're passing in target X and target Y values. Oh man, this is so not going to work. Okay. Cool. Is it going to go? Wait, hold on. All right, cool. Things are looking pretty good. I had to remove the absolute value functions from this dxdy calculation because right here in set target, we're passing in either a positive or negative offset to shift the camera. And when I did this comparison, I was taking the absolute value. So if it was negative, it was sort of being nerfed, and the camera would only ever move in the positive direction, which caused all sorts of interesting issues. But now, if we have a look, we can see that as the player moves this way, the room updates. Player moves this way, the room updates, and so on and so forth. And we can move in all 4 directions, and it does not appear to be blowing up, which is good. Now, one thing I'm curious about is if we take out one of these baddies, does that remain in the state? We move back. Ah, there's only one. Good, so it's persistent. That owns. Okay, cool. So I think we can call rooms done. So let's have a look at our spreadsheet. I think it's spreadsheet time. Okay, so rooms. We've done multiple rooms. We can color that in. Rooms can have baddies. We can color that in. Rooms don't have shutters, and they will eventually have items.
the camera does update on room changes, and then we just need shutters and items. So I think the next thing to work on is probably shutters.
Thanks for watching, folks. Sorry those darn rooms took so long, but hey, we got there eventually, and that's what matters. I hope you're finding these videos useful, and if you're doing any development of your own, that your efforts are fun and fruitful. And I'll catch you next time, and we'll do those shutters. Bye for now.